And there are step 3 as remove all the equipment, all the legacy equipment, including all the antenna, all the coax cable, all the cabinet, and everything. Take them down and bring to the warehouse and recycle. That's the step 3, right? Also, that's step 3. We try to be involved with that project too. All right. Yes, sir. Depends. 거기에 대해서 따로 좀 설명을 드리겠습니다. 그래서 우리가 지금 하는 일을 AIS, Air Interface System 그렇게 얘기하면 딱 거기에 맞아 떨어질 것 같습니다. 캐비넷을 지나가지고 에어까지, 타워 꼭대기까지, 안테나까지 그냥 통상적으로 에어 인터페이스를 합니다. 에어 인터페이스 시스템. 그래서 AIS 이렇게 부릅시다. 그래서 셀 사이드 컨피규레이션을 그 타입으로 보면은 에어 인터페이스 뭐가 있냐면은 모노폴 안테나, 안테나별로 보면은 두얼 폴 안테나 있습니다. 이게 타이틀을 제가 좀 잘못 잡은 것 같은데 모노폴 여기에 대해서 이제 안테나가 어떻게 진화되고 있는지 지금 저 잠깐 좀 보겠습니다.
갑자기 당황했어.
Yeah, I'm sorry. I keep forgetting. Sorry about that. All right. Let's see antenna. How the antenna migrate from old to new antenna. Very old system. There's one RF connector either at the bottom or from the back. It's we call the bottom feed or back feed, right? And there's one connector. There's only one antenna. The array of the antenna radiator inside. It's we call the monopole antenna. Monopole, right? This type of antenna we call the monopole. This antenna, two antenna becomes a dual pole antenna. So two antenna becomes one. Right? There's money involved, or it's money. Right? When you lease some space, right? They want more money. So all right, now we have a one. Right? All right. Let's make it a little bigger, just the illustration purpose only. Okay, this is a electrical tilt antenna. All right, about a decade ago, there's a new standard coming. Right. So different is before. Right. This is tower top, right? Whenever there's we call it performance. You guys maybe heard of performance, RF optimization, those kind of a term, right? So then what that is like try to adjust the network to serve the customer better, right? So when another one is when they putting a new cell site. This is cellular concept real quick. Long time ago, there's like one big antenna, tall antenna, serving everywhere, right? And there's more customer coming, but there's a limited resources, the frequencies. So they start putting a small antenna, covering small area, and we use the frequency, right? This is cellular concept, right? Cellular concept, right? So when they simply, this is cellular concept. they have a network, and right, and when they have more customer, they need more capacity. They simply putting a new cell here, right? And now putting the antenna here, there's a two factor here, right? Main the signal I want to use is we call the carrier, right? The signal we don't use we call the interference, right? So if putting this one, now they interfere more. So what they need to do, they just reduce and adjust the coverage like this, right? So give a room for the new cell site. In order to do that, there's many ways they can adjust the power from the base station, right? Another way is we call it down tilt. Down tilt or azimuth steering. Down tilt is right. There's a antenna when the antenna radiating a signal, that we look at it two plane. One is a horizontal plane, another one is a vertical plane. Right? Horizontal plane, you basically look at the the signal from the top. It shaped like this. Right? And if you see this signal from the side, it's shaped like this. Right? This is a horizontal pattern. This we call a vertical pattern. Right? So down tilt is simply controlling this vertical pattern. So this signal or this signal will go to the air. This is useless, wasting energy. And this one also possibly causing interference to other side. So what they do is just simply pushing this beam to the ground. Good thing is that this is a good technology to to optimize the network. So simply increase the C and reduce I. That's how what it does. But if you do too much, you lose your coverage here, right? So that's what it is. And that's what we call the down tilt. And beam steering, azimuth steering, is a horizontal pattern control. So this is the coverage. We like to cover this area more. If there's a customer complaint, hey, I have the pretty bad service here, they can rotate the antenna to this direction, right? That's a beam steering. In conventional antenna, in order to do that, someone have to climb the tower. Someone have to climb the tower, pushing the antenna down, or change the antenna orientation, right? Climbing tower, how much cost? At least $1,500. And used to be very expensive. Now just prices come down a lot, but used to be very expensive. Sometimes like a power tower. There's a power pole. There's a top of it, the power pole. There's some antenna installed. You may see that kind of thing. Easily $10,000. Right? So because of this one, they start introducing electrical down tilt. Right? This body to govern this standard we call the AISG. The air interface standard group. Right? That one define all the standard. So electrical down tilt is simply controlling, pushing the beam down electronically. How? By the controlling phase, right? Earlier, we see this antenna like this, right? Here's the RF, right? So when deliver the signal to each radiator, right? There's a time delay. there's a time delay here. Even though short cable, long cable, small lengths of cable, but there will be delay. So controlling this delay, right? Control this delay. Now they can adjust this beam up and down. Okay, that's beam steering. I'm sorry, that's electrical down tube. The beam steering, how they come up with is like especially KMW. KMW is the first company to introduce the beam steering, and still not many companies do. Beam steering is simply rotating. There's many ways to configure this way. Is rotating. There's a motor, stepping motor, rotating the whole antenna inside, not the outside. Right? Inside there's room. I'll show you that antenna right there. It's a shape like a circular shape. So inside there's a room to turn this whole antenna radiator. That's beam steering. And now the next generation antenna, the beam down tilt, beam steering, and azimuth. I'm sorry, beam width. Beam width control. This is a 3-way antenna, right? Beam width control is earlier we see here, right? This is the coverage. But what if they complain interference here? So what they want to do? Like show them the coverage like this, right? In order to do that, they have to replace the antenna, right? But we don't want to do that. So now they putting a many way. This is the KMW way. They have a 3-way, so they adjusting. And this is 3 separate section, open, the in and out, adjusting, controlling the beam width. And Andrew or CommScope come with like a 3 separate column. And electronically controlling, how to feed this signal to 3 separate one. It doesn't many way, but cut it short. That's antenna. Next generation antenna will be the intelligent antenna. Still, cost is very expensive, right? And finally, right, let's get back to our antenna. Now another trend of the antenna is multiband.